There we go, alright. Hi, if you don't know me, I'm Simon. I'm the main maintainer of the Haxe compiler, and I'm going to give you the sort of keynote. So basically this is a report of what we have been doing this year. So if we look at the timeline of 2018, what has happened so far? We had a 4.0.0 preview.3 release in February, and then in May, Nicola was talking about the Haxe 4.0 progress at the Haxe Summit in Seattle. Then after that, we had a preview 4 release in June. In September, we had the first ever Haxe Evolution board meeting. And now in October, we're here at the Haxe Hub. So what I'm going to talk about is basically this area from June to October, because Nicola already said what we've done before. So first of all, let's look at what kind of activity we had in that time. We had about 900 commits since preview 3 by 37 people, which I think is pretty good. Our open issues went from around 900 to around 600, although I've seen that Kevin is trying his best to get it up. And we get it back up, we have like, it's almost at 700 again, I think now, so yeah, I hope we figure that out. And I want to give thanks to a few people. First of all, George Coney, who showed up to take care of our HTML externs. And I don't know, he kind of came up out of nowhere and said, okay, I'm going to work on the HTML externs now. And that's really nice because they have been a bit neglected. And I very much appreciate that he's doing this. So thank you for that. Also, we had Ben Morris, who did some work on the OCaml side of things, and he cleaned up our command line interface. If you use the command line on Haxe 3, you get like a really ugly looking sort of output. The help looks terrible, and now it looks less terrible. It actually looks pretty nice now, and that's thanks to him. And then of course I have to thank the usual suspects. We have Andy, our CI firefighter. There have been a lot of occasions recently where I'm like, Andy, the Flash on OS X isn't installing anymore. And Andy's always like, I'll look into it. And he actually does. And that's really nice, because without him, our CI would be not working properly, to put it mildly. Then of course we have Jens, Gamma 11, who works a lot in Visual Studio Code. I've been working with Jens together. I'm on the Haxe side, he on the VS Haxe side, and we've made some great progress in general. And he also works on a lot of other stuff. I always joke that he takes part in every other Haxe project there is, and that's probably true, so thanks a lot for that. Unfortunately, he's not here, but I'll try to get him next time.
We're working on it.
Then of course Kawe, he's not as active as he used to be, but when we have problems with our nightly builds and we ask him to fix it, he usually does, eventually. So thank you a lot for that, Kawe. Then of course we have you, who still takes care of HXCPP. Justin, who takes care of Lua. Alexander, who takes care of PHP. That's you, thank you. And there are plenty other people, but this slide ends here, so I only have one more, which is Nicola for his work on HL, and of course his many good ideas that he brings to Haxe and has always brought to Haxe and will always bring to Haxe. So thank you a lot for that. So one of these many good ideas, the big one, he has been talking about this for a really long time. And I think over the past 3 years or something, he has announced that it would almost certainly be in the next Haxe version. And it never really made it. But this time we actually went for it. So I'm going to talk about this. You all know what's coming now. And it's been a blast to work on this, and I'm talking about, of course, overload is now a keyword. Just kidding. I'm talking about Unicode, of course. So let's look at this. What am I talking about here? So if you look at Haxe, you can say Haxe is great And if you get the length of that, it's 14 on every target, I hope. And that's just great. Thumbs up to that. However, if you translate this to French, and as we all know, translating this to French means adding this guy here. That's French. And if you do that in Hex 3, well, you might get the 14 that you expect. And sometimes you might get 15. Bless you. And that's not so good. And that's basically what we've been working on. So all the effort we put into this was so that this now gives 14. And in fact, in Hex 4 on all targets right now, this is true. And yes, thank you. That's a great achievement. We've been working on this for a long time. And you can even say it in Japanese and it's still going to work. And I hope this says Hex is great. I'm not quite sure, but yes. So this now works. We have Unicode support. So let's look at how we got there. First of all, if we just look at our targets in Hex, what do we have? We can put our targets in categories, and one of that category, of course, is ASCII. So just straightforward byte representation, and that includes C, C++, Lua, PHP, the old macro interpreter, and Nico. Then we have UCS2, which is JavaScript and Flash. We have UTF-16, which is Java and C#. And then we also have UTF-32, which is Python, I think. Heinz tells me it's UTF-32. If you look at Stack Overflow, people tell me it depends. It's basically a compilation setting, but it's in one of these categories. So it's covered, is what I'm getting at. So what do we do with this? How do we get some notion of a unified Unicode representation? And I think Nicola made the only sensible choice here, and that is to say we support at least UCS2. We don't say you have to use UCS2, you have to use UTF-8 or whatever. We just say support at least UCS2. We allow UTF whatever, and that of course means we have to deal with all our ASCII targets. So C, that means hash link. C++ is of course HHCPP, Lua, PHP, the new macro interpreter, and well, let's ignore this guy for now, okay? So first of all, why doesn't everyone just use UTF-8? I made a blog post about our Unicode support, and some guy on Twitter was really surprised that we don't just use UTF-8 everywhere. Because UTF-8 is used a lot, but well, at a low level it has some challenges, and I really want to get the point across why that is. So the problem with UTF-8 is that it has a variable length, which means we have a very slow random access. And why is that? If we look at just the substring Haxe is with that French E, you can see most characters are represented by 1 byte. And this guy, unfortunately, is represented by 2 bytes. So the problem now is if you want to get the 5th character, you can't just do 0, 1, 2, 4, 5. You would end up here, but you would only get this part, and that's not correct. So you cannot do that. You always have to walk every single byte and see if you have one of these guys, because otherwise you get the wrong offsets. And that means, well, of course, the problem actually is that our string API focuses heavily on carcode@, and that is technically random access. I'm going to talk a bit more about that technically a bit later, but the thing here is we have linear lookup instead of constant lookup, and that's really bad. It might not look so bad in an example like this, because this is a very short string, so it doesn't really matter if we go here by 1, 2, 3, 4, 5, 6, 7 steps. It's not a big deal. But if that string gets longer, it becomes a big deal, and I'm going to show you some numbers regarding that a bit later too. So, why might UCS2 be the better solution? And, well, that's easily answered. UCS2 is a fixed length string representation, and that means it has fast random access. We can look at the same string, and what happened now is that all these guys are now 2 bytes as well. So if we want to have the nth character, we can just go to this position and we know exactly where to find it. And this is always going to work, and it's always going to be fast, and that's good. UCS2, of course, also has some downsides. It uses more space, obviously, if we compare it to UTF-8, which is much more compact. This is much bigger. And because we use only 2 bytes, we can only represent the basic multilingual plane, which is this number of code points. It's 2 to the power of 16. And that means, well, what do we do with characters that are outside of the BMP, the basic multilingual plane? We have to represent it as a surrogate pair. And that, unfortunately, includes emojis. So that's really sad. What's a surrogate pair? It just means that the character consists of 2 code points. So if you trace this sad guy, the length of this sad guy, on Java or C# or JavaScript, you get a length of 2, because this consists of 2 code points. And that's the same for UTF-16 and UCS2, which is why it affects Java, C#, JavaScript. So I'd say that this is not really good. It's, from a user perspective, you don't want to worry about this. But if these guys do it, I mean, we can kind of justify doing it as well, right? It's okay. And the other issue is, it's not like we could avoid this, because these targets natively use this representation. So what could we do? We would always have this issue, because we cannot just avoid their internal string representation. So it's not like we can get rid of it on all targets. It's always going to be around, and, well, that just means it's a valid representation that we can choose. And we did choose it on some targets. So this is now the representations we use in Haxe 4. Lua, PHP, and eval are using UTF-8. JavaScript, Flash, Hashlink, and C++ are using UCS2. Oops. And these guys, of course, still use UTF-16 and UTF-32, I think. So this is what we have. And unfortunately, we left one guy behind. Poor Nico is gonna stay ASCII. We're not going to update it, so I'm sorry, Nico, but it just had to be done. So don't try to use Unicode on Nico. Use whatever else, not Nico. Okay? Okay. So, of course, this means that some people had to do more work than others. Lua had to do a lot of work. PHP had to do a lot of work. Hashlink had to do a lot of work, and C++ had to do a lot of work. And then there's, of course, my new macro interpreter, eval. And yes, there was a bit of work. So let's talk about that. Unicode in eval, or as I like to call it, my 5 stages of grief. And it started with the usual denial, so I kind of pretended that the issue didn't exist. But somehow that didn't help. So I was bargaining with UCS2, and it kinda, sorta seemed alright. Then there was a certain anger about emojis, of all things. But yes, it was actually emojis.
Did you express that in emojis?
Yes, I did express that in emojis. And that anger led me to be sad about a slow UTF-8 implementation. And finally, I reached acceptance of a fast UTF-8 implementation. So, let's go through that. I'm gonna skip the denial step. You can look up my Steam list if you want to see more information on that. So, the UCS2 implementation. The idea was to distinguish ASCII and non-ASCII strings. So each string would know, is it ASCII or is it non-ASCII? And for ASCII strings, we could just use what we used before, direct access. And for non-ASCII, we kind of have to shift everything left and right by 1. That's the thing I showed before. In this situation, you kind of just have to double the input and then maybe take half of the length and things like that. So it's basically really a lot of shifting around. And that looks in GoCamL something like this. If the string is ASCII, then we get the string at the index, and otherwise, oh, that's the doorbell. I think the Dutch guy is arriving, that's good. And otherwise, this means logical shift left, so it's these guys to the left by 1. And there was a lot of code like that. And it was a huge if fest in the entire string API. It was not good. And the other problem was, we still have to convert everything to UTF-8 for the actual OCaml interrupt macros, because these guys still expect a UTF-8 representation and not this white UCS2 representation. So there was a lot of conversion going around from UTF-8 to UCS2 and back to UTF-8. And I was looking at that and thinking, well, this is fine. It's a good solution. No problem here whatsoever. So, keep in mind, hey Mark, welcome. Please take a seat.
Morning.
So none of this really bothered me to the extent that I would say I should do something else. And then we talked about emojis. So I had an argument with Nicola about string iteration, and the basic question was, if we do this, what output do we expect? And there are two possible interpretations of what this could do. One is, it should just print the car code of the emoji. Done. And the other is, it could print on targets that have surrogate pairs the 2 code points of the surrogate pair. And I don't like that idea. I don't want my users to worry about surrogate pairs at all, because I don't see why they should. It's basically an implementation detail that surfaces here. I know we still have the problem in some targets, we can't do anything about it, but on my own target I figured this shouldn't be necessary. So let's go UTF-8. And again, all this didn't bother me, but this was enough to make me go, let's just use UTF-8 instead of UCS2. Okay, so slow UTF-8, just a straightforward implementation. We accept the linear lookup on random access. And the unit tests seemed kind of sort of alright. They compiled, it wasn't particularly fast, but it finished. And then I tried to run docs, and docs didn't even terminate anymore, I think. I'm not sure if it would have terminated at some point, but I don't think in a human lifespan it would have, so not sure. So to summarize, that was a bit bad, not good. So this isn't going to work. What can we do? And this actually started with an idea Joy gave me about a thing. Well, first of all, the realization was that string access is not truly random, typically. You don't jump around in your string from beginning to the middle to end, at least not on very long strings. You just don't do that. So you operate very locally on a given string. And that led to the idea of a cursor in the string. So what this would mean that each string instance would keep a tuple, which is a mapping of a character offset to a byte offset. So you would know that character 5 is at byte offset 7, for instance. And then, when we want to look at a different character offset, we would check the distance to the character offset we already have. And if that's small enough, we could just calculate the byte offset we want from the byte offset we have. And then store the result as our new cursor tuple. Pretty straightforward, I think. I just didn't have the idea. I don't know why. It's probably how everyone does it, but... So if we look at this, if we have like this kind of string, and we're interested in these two guys, and notice again there's this guy here, the French E, yeah. So let's say we have the position of this F. It's the 5th character, starting at 0, and it's like the 6th byte position, because this guy is a bit fat, right? So it takes up 2 bytes. And if we're interested in the 10th character, well, now instead of going from all the way over here, we only have to go from here. And that means we only have to do 5 steps instead of 10, because it's only 5 characters we have to cross over. That doesn't sound so impressive, but if we imagine that this string was a bit longer and just add an arbitrary number there, you can see, yeah, this might be a bit better than this. Just a little. And that's the basic idea that we went for. So, for some reason, this implementation even turned out to be faster than my previous UCS2 implementation, which makes no sense at all. It shouldn't be faster. It just shouldn't be. And it probably means that the previous implementation was not so good. But anyway, some more details on these cursors. We don't use these cursors on very short strings because it's not worth it, plain and simple. If you have a string of length 5, you can basically always start from the beginning, because in worst case you go 5 steps, and that's okay. That probably doesn't warrant the additional memory we use, so that's fine. On the other hand, we allow adding a second cursor if we jump around in the string a lot. That can happen if you operate on the string from both ends. So if you have the beginning and the end, and they kind of move towards each other. That wouldn't really work with just one cursor, because you would always go from the beginning and then jump to the end and back to the beginning and back to the end. So in that case, we just use 2 cursors. And we also always use the 0 point as a pseudo cursor. So that really just means if we determine that our distance from the cursors we have is further than the distance from the beginning, then we just start over. And we can move this cursor, of course, but we can still use it as a starting point. And I'm sure that you can find artificial examples where this is still slow. I'm not quite sure how you would do it. You would probably have to access the string truly randomly. And something in the beginning, then jump to the middle, then get the other cursor near the middle as well, but not far enough so the middle cursor moved there. I'm sure it can be done, but I'm not sure it could happen in practice. So if anyone wants to find a good example of where that happens, then feel free to. I'm probably going to ignore it, but you're free to try it. Okay, and that's... Well, let's see some numbers actually. So this is where the optimization that I implemented. We have a string of length 1 million, and you can see in the fast code at offset 0, it's always going to be the fastest because we don't have to do anything. We can just get the first character and be done. And in the other situations, this is probably within the margin of error, I'd guess, because I don't really see a reason why this would be faster than this one. But that's also not really the point. You can see that fast code add is a bit faster than car code add, which is a good, because this is called fast, it makes sense, I think. So it's a bit faster, so yeah. And yeah, this is basically what you would expect. It's fast at 0, and it's kind of the same at the middle and at the end of the string. Now, without that optimization, I tried that yesterday out of curiosity, we get a bit of a different picture. So at 0, it's still fast, and it's actually faster than here, of course, because we don't update any cursors or anything like that. So that means it's going to be a bit faster. And the same is true for the car code add. It's also going to be a bit faster. But then if you look at these guys, well, that's like 1, 2, 3, 4 orders of magnitude slower. And that's pretty bad. So you can also see the linearity here, because this goes to the middle of the string and it's at 340-ish. And this goes all the way to the end, and it's exactly at the half point, so it's at 170. So you can really see that this guy only has to walk to the middle each time, whereas this guy has to walk all the way to the end. And that explains these number differences. And this also explains why docs wasn't terminating anymore, because it's just not good. Really not good. Yes, and I think that's all about Unicode. Yes, we're done with Unicode, so thankfully, yes, thumbs up from the door. Yeah, we always want more coffee here, I think.
Yep.
So let's talk a bit about non-Unicode stuff, just to relax. Key value iterators is one thing I'm going to talk about, and inline call syntax is another new feature I'm going to talk about, which we kind of sneaked in. Then type level using, this is actually a really good one. Yeah, and XML literals, you can go. You. Yeah, XML literals are also a thing now. And then enum values as default function argument values. I couldn't find a short way to express this, but yeah, I'm going to mention that as well. So let's look at key value iterators. And that basically just means that you can do a for key arrow value in something trace key value. That's the basic syntax, and we already support it in map thanks to the great work of Mark. So that just means if you have a map like this, you can iterate over the key and value of that map, like so. And this is going to print you 1 value and 2 value. Probably not in this order, but it's going to work. And it's also pretty fast because everything is inline, so the generator code looks really good. And you can use this feature in any data structure, the same as iterator actually. So you just add this key value iterator field, make it return a structure key value, and you can start iterating over your structure. We currently have plans to support it on array and string. It's not quite done. Several people are working on it, but working with array and string is always a bit messy because you have to do a lot of platform-specific changes for these guys because they are really optimized for each target. So yeah, it's a bit messy, but we'll get it done for Haxe 4, for the final Haxe 4 release. Yeah, that's all I have to say about key value iterators. Then the inline call syntax. It's really quite straightforward too. You can now use inline on any call and it's going to inline the function, even if the function isn't declared to be inline. So in this example, we call it here inline me maybe, and then we call it within this loop because we figure within the loop it should be fast, right? That's usually what you do. So we just say inline me maybe. And if you look at the generator code, that's exactly what you expect. We have the normal call, and then within our loop, you can see it was inlined. And yeah, that's really all there is to say about this. You can also use it for constructors, by the way. So if the constructor can be inlined, it will be inlined. There might be reasons why it cannot be. I forget if you get an error in this case or not. We should probably look into that, but yeah, that's all there is to say about inline call syntax. Then, type level using. This is actually, I think, one of the most interesting features, even though it's a really small one. And there are more people arriving. So type level using, what does that mean? You can take any type you like, for instance an enum, we make our own. Hey, welcome. Please take a seat.
Hey.
Hi.
Hey.
Welcome.
Even more chairs.
What? I'm running out of chairs? Success!
We'll be fine. We'll be fine. Take a seat. So, as I was saying, you can take any type like an enum. We make a custom myOption enum, and then we using myOption tools, which is this guy. And what this does is that every time you use myOption as an instance, you automatically get this as a static extension. So that just means that you can do this. Assuming this sum is an instance of this, you can just use get. And that works with any type. And I think it's particularly useful for enums because right now you cannot really put code that belongs to enum on the enum itself. And using this, you can do it in a way that is nicely separated, and yeah, it's really simple. It was really simple to implement, but I think it's really powerful too. So yeah, that's one of my favorite features actually. And then there's XML literals. That was another one where we had a lot of discussions. I'm blogged about this after the Amsterdam Summit because everyone wanted to talk about it, and we did talk about it, and we did talk about it afterwards too, and I think we're still talking about it. And the basic idea is that you can now do this. So you declare a string by using an, what's that called, an angle bracket opening and some identifier, and then that keeps going until you close it. And it also counts if you open another one and close another one. So this from here to here is going to be a string, right? Great. So what can you do with this right now? And it's very useful to get a compiler error because the compiler is going to complain about this has to be processed by a macro. It's also very useful to mess up syntax highlighting in IDEs and editors because nobody supports that right now. And it's also great to be, if you want to be nostalgic about the time you wrote ActionScript 3 because it has that feature too. So it's a great feature. But what you can also do with it, or you can feed it to a macro and then do whatever you want with it. And I think that's the basic idea. That's what the people want to do with it. And I expect great achievements from the macro community, which is sitting over there. So
Yeah.
So this is what we want to do with it. And yeah, that's all I have to say about it, really. It wasn't particularly hard to implement. We discussed it for months and months, and now we have it, and let's see where it goes. And then the final thing I want to mention is that you can now use enum values as default function argument values. And that just means that you can put none here. So you have a function argument and the default value is none. And if you call that without the argument and return the value, you get none. Yeah. It doesn't work with constructors that have arguments right now. We're not sure if we want to support this. There are some considerations to be made there, but for now it's just constructors without arguments. Okay. And now you might be wondering, so when can we test all this? Because some of these features sound great and I want to use them, and well, the obvious answer is you can test it once Preview 5 is released, right? Okay. Let's try this. Let's try to make a release here. Let's see. I prepared some things, but still, oh dear. See, this is a MacBook, and I'm terrible with MacBooks. So let's see. Yes, that might happen. Something like this might indeed happen.
He's just going to destroy Haxe retroactively.
I'm very brave for trying to do this, I just want to point out. So
You are.
we have to write some release notes. So what I usually do in this case is grab the previous release notes. Let's go to Haxe.org. And that's 347. And yeah, this sounds good, right? So let's take this. How do I copy on a Mac? I don't know. I just right click. Okay. Let's use Haxe preview 5. Yeah, this still applies. And Haxe 4. I shouldn't change that to Haxe 5. And yeah, that sounds good, right? That's okay. Okay, how do I save a file on a Mac? I don't know.
Command S.
What's command?
Command
S.
S, like the Windows thing.
Okay, and now for the fun part.
I'm a Mac Pro.
Let's see what happens if I do this.
And he says, why would you do live coding if you can do live releases instead?
Let's see what happens here. Uploading sounds good.
Maybe Unicode is in process. Like with docs.
So it might upload? Maybe.
Any day now?
I mean, my upload isn't very fast, so this might take a while. And I guess while we are doing that...
There's a stream also.
Yeah, right, the stream. That might be another problem. Okay, we get a...
Broken pipe.
Broken pipe. My pipe is broken, that's not good. Okay, I figured this wouldn't work. I wanted to try it, but I'm going to make the release on my real computer over there after this stream, so...
On the real computer.
Yes, on a real computer. So, that's it from me. Thank you, everyone. Yeah. Any questions?
So we have one
Yes.
that I'm going to just read it out.
Yes, do it.
But are we going to get inline var for local variables? Love creating static inline vars for inline variables in one function.
What?
Weird face. That's
Inline
what
var for local variables. Oops. Inline var for local variables. No. The problem is that for that to work, you would have to know that the variable is only assigned to exactly once. You kind of need an SSA representation in order to do that. And I don't think it's worth it to worry about that. We could do it for final variables. We could maybe. If a variable is final, then and is assigned to a constant, that might be an option, yeah.
But won't
So-
the analyzer do this kind of stuff anyway?
Probably, yeah. I think it should do that. The analyzer should do it automatically anyway. So if you have a constant assigned and the analyzer figures that it can propagate that constant, you should probably get that result already. So, yeah.
Okay.
Yeah. Anything else?
Yes.
What? Would it be possible to have XML literal support for tags without names? In React, we have fragment that can be expressed as a short answer, no. And we can discuss this later. Okay?
For React fragments. In React you can just write.
Yeah, you can write
So,
bracket, bracket.
yeah.
And
An anonymous tag if you want.
I don't know if I want to support that. I'd have to think about that, and I'm not sure it's worth it really. Because you can just use some identifier there. Is my basic contention, so probably not. Anything else?
That's all.
That's all?
We
Alright.
had another question
Yes.
at the very beginning
Okay.
when you were talking about Unicode.
Yeah.
When will Haxe support any other runners except of run.n?
It's planned. We have an open issue for that. Nicola wants to replace hashlink, Nico with hashlink in that regard. So the question was, when will Haxe support other runners than run.n? And the idea is that we want to support the macro interpreter for that, and also hashlink in case you have to do more heavy work, I guess. And I can't tell you when, but I can tell you that it's planned right now.
For what it's worth, Haxe already supports the interpreter.
It does, right? Yeah, it does support the interpreter
You have
already.
to
You need
put
to
a
run
main
HX.
class in your hex.json and then it
A
will
run class or
A main class.
main class, I think. Or
yeah, you have to put
Read the
some.
code.
You have to put some class in your hexlib, and then you can run it through the macro interpreter. I forget the exact class name, but it does work. And as I said, the plan is also to make it use hashlink. Okay.
Great.
Anything else? Okay, thank you very much.
We're gonna take a coffee break.
Yes, we're gonna have a short break and then we'll be back. I'm going to just leave this open because I don't have a pause screen for this, so thank you.